All right, let's continue to practice graphing some quadratics, okay, that are in standard form. I want to graph the quadratics, find the x-intercepts or roots, the y-intercept, the vertex, and a table if we need to, okay? First thing I want to do is find the x-intercepts. We'll define our x-intercepts. I'll set my function equal to 0, x squared minus 4x minus 5 equals 0. And my goal is to factor and solve this. Now, if I want to use the quadratic formula, I can use the quadratic formula as well. I'm going to factor this one, and then at the end, I can show you quadratic formula work. Okay, so to factor this one, I need to find two numbers. Now, you could be able to do this in your head maybe, but if not, I'm going to write this out. That multiply to negative 5, and those same two numbers must add to give me negative 4. All right, well, they're only 5 is a prime number. Since 5 is a prime number, the only numbers that'll multiply to 5 are 5 and 1. If I want a negative 5 and negative 4, okay, if I want to add these two numbers to negative 4, then the 5 needs to be negative. So this, remember, would factor as x minus 5, x plus 1, and that's equal to 0. From here to solve, I'm going to set each factor equal to 0, x minus 5 equals 0, and x plus 1 equals 0. Solve the first one here by adding 5 to both sides to get x equals 5. Subtract 1 to get x equals negative 1. So, right away I can tell you that my x-intercepts are 5, 0, and negative 1, 0. So I can plot those right away. Boom. All right. Next work, I want to find the vertex. To find the vertex, I can count to the middle here using the graph, or I can do the actual work by finding the average of my two x values, 5 plus negative 1 over 2, which is 4 over 2, which is 2. So my vertex, I know the x value is going to be 2. Well, how am I going to find the y value? I'm going to find the y value by plugging it back into our original function here. Okay, so original function, remember, was x squared minus 4x minus 5. All right, well, now it's going to be 2 squared minus 4 times 2 minus 5. 2 squared is 4. 4 times 2 is 8, and then minus 5, which is negative 4 minus 5, which is negative 9. So my vertex is 2, negative 9. I'm going to write this as y equals, sorry. All right, again, I plugged in 2 for my x value into my original function. Okay, and the answer, my input was 2, my output was negative 9. So my vertex is 2, negative 9. That's a 9. Doesn't look like one, so I'm going to rewrite it for you. Don't you worry. There we go, 2, negative 9. 2, negative 9 is right there. Let's make a point. Wow, is this a minimum or a maximum? Well, I noticed that my a value, my first term, my squared term, is positive. So since it is positive, that would make this a minimum. Axis of symmetry is always the x value of my vertex. So here it's x equals 2. Y-intercept. Let's do some work to find the y-intercept. So to find my y-intercept, I plug in 0 for my x values. All right, my x is equal to 0. Some of this we will do as part in our head, and that's totally fine. 0 squared minus 4 times 0, that's a 0. Don't be a hero, chalo. Minus 5. Remember, Mrs. Logus said that the x terms will cancel out. So this will be 0 minus 0 minus 5, which is just negative 5. Again, my input was 0. My output was negative 5. So that's my ordered pair. 0 was my input. My output is negative 5. Now, some of you may be able to recognize, hey, it's just our C term. Yes, our holy buckets. Our y-intercept will be our C term. Okay. There's 0, negative 5. So I'm going to go ahead and connect my points here. All right. We look to have somewhat of a parabola. And if you want some more points, then you can always create a table using any of the x values in between or any of the x values on the outside of our intercepts as well. Okay. Domain and range. All right, domain. I'm always going to be able to plug a negative x value in and always going to be able to plug a negative y, or excuse me, a positive x value in. Everything to the left is included. Everything to the right is included. Therefore, it's all real numbers. And we write that as negative infinity to infinity. The range, remember the ranges are my y values. The range I read from bottom to top. What's the bottom? My lowest y value. My lowest y value here is -9. So my range will start at -9. And my highest y value I cannot see. So that'll go to infinity. Wow, that's the first problem. That was so much fun. I can't wait for number 2. Let's talk to it. Here we go. Number 2. F of x equals -x squared minus 6x minus 8. Wow, that's a lot of negatives. Don't you love negatives? I do too. Okay, so to find our x-intercepts, we're going to set our function equal to 0, -x squared minus 6x minus 8 equals 0. I'm going to try and factor and or use a quadratic formula to solve this. I don't like doing factoring with a negative x squared, so I'm going to take a -1 out. -1 is my greatest common factor. Remember, when you factor, you should always ask yourself, is there a greatest common factor before starting? Okay, there is a greatest common factor of -1. Now I want to factor this. X squared plus 6x plus 8. Find two numbers that'll multiply to give me 8, and I'll add to give me 6. This is called the Foster method of factoring. I love it. I heart it. I heart it. I heart it, just like I heart math. Factors of 8 are 8 and 1, or 2 and 4. Holy buckets, 8 and 1 can't add to 6 and multiply to 8, so it's got to be 2 and 4. Isn't that neat? So neat, so neat, so neat, so neat. Here we go. This becomes x plus 2, -1 comes down, x plus 4, and that's equal to 0. Set each factor equal to 0 and solve. Now, a common question, do I set the -1 equal to 0? If I set -1 equal to 0, is that true? No, it is not a true statement. The only time, look at that fish, the only time we'll have to do this is if there's an x there. All right, if there's a variable there, then you'll have to do it, but in this case, there isn't. If I subtract 2 from both sides here, and I don't know if we'll do that this year. I get x equals -2. Subtract 4, I get x equals -4. Intercepts roots -2, 0. And -4, 0. Plot them. It's a little hard to plot a point with this little stylus here. It's kind of tough. I'm doing my best here. Got a battle? Got a battle. Okay, so find the vertex. Again, to find the vertex, I take the average of my two x values, or I can just count in the middle. For this problem, it might be easier to count, but I'm just going to do this work anyway since I heart math. -2 plus -4 is -6 over 2. -6 over 4 is -3. So I know the input, my x value, my vertex will be -3. Okay? My input is -3. I got to find my output. So y equals the -3 squared. Okay, I'm sorry. I'm going to rewrite my original first before I start doing this. That'll help us. So I have -x squared minus 6x minus 8. All right. So I plug in -3 now. So it's -3 squared minus 6 times -3 minus 8. Now, remember when you do this, that order of operations says to square the 3 first. And hold on. Apologize, thought someone was at my door. All right, but no one was. So here we go. So -3 squared. This is going to be -1. -3 times -3 is just +9. -6 times -3 gives me +18 minus 8. So it's -9 plus 18 minus 8. Well, -9 plus 18 is 9. 9 minus 8 gives me 1. All right, so when you plug this in your calculator, be careful that you have the -1 on the outside and make sure you put the -3 in parentheses. So my input was -3. My output was 1. All right, since my output was 1, that's my vertex, negative 3, 1. So I'm going to go here, negative 3, 1, and make a dot. Okay, notice how my A term, my square term, was negative here. So that tells me right away this is going to be a maximum. You can tell as well, look at how my vertex is above my intercepts. My vertex is above my intercepts. It only makes sense that my graph is going to be pointing down. If my vertex is below the intercepts, then it only makes sense the graph is going to be pointing up or opening down. My axis of symmetry is always x equals the x value of my vertex, so it's x equals negative 3. Y-intercept we're going to find, so let's find our y-intercept here. So y-intercept, I'm going to plug in 0 for y. Excuse me, not for y, for x. Holy buckets there. Watch out. No. Don't do that. Plug in 0 for x. Cholo. So what happens? This becomes 0. This becomes 0. Minus 8. So my input was 0. My output was negative 8. Input was 0. My output was negative 8. 0, negative 8. Make a dot, and I'm going to connect them now. Okay. Holy buckets. Whoops. Okay, did not mean to do that. Holy buckets. Here we go. Wow, this has been a struggle, people. Okay. And I'm going to do my best. And there we go. Okay, that's not great, but I tried. All right, my domain, negative infinity to infinity. My range is a little bit different this time, okay, because my range is going to be, well, remember it's bottom to top. Well, I can't see the bottom of this graph. Since I can't see the bottom of this graph, it's going to be negative infinity. My lowest possible y value is negative infinity. I cannot see it. These arrows go on forever. The highest possible y value, bottom to top, the top is positive 1. Okay, so in this range, our constant comes second. All right, so I told you I would do the quadratic formula. I'm going to do that at this point. If you're good on the quadratic formula, you can go ahead and. All right, here we go. So I got my A is 1, B is negative 4, C was negative 3. Remember, this is our quadratic formula here. Okay, I'm going to scroll down and show my work. Negative B, or opposite of B, is positive 4. B squared, so negative 4 squared minus 4 times 1 times negative 5. All over 2 times 1. I know that negative 4 times negative 4 gives me positive 16. I know that negative 4 times 1 is negative 4. Negative 4 times negative 5 gives me 20. 16, 2 times 1 is 2. 16 plus 20 gives me 36. And now I'm going to split it. Square root of 36 is 6. So 4 over 2 plus 6 over 2. 2 plus 3, x is 5. 4 over 2 minus 6 over 2. 2 minus 3, x is negative 1. That was the first one. Second problem using quadratic formula. This should say a, not x. Sorry about that. A is negative 1. B is negative 6. C is negative 8. I didn't include the quadratic formula in this one, so opposite of B is 6. Plus or minus square root of negative 6 squared minus 4 times negative 1 times negative 8 all over 2 times negative 1. Negative 6 times negative 6 gives me positive 36. Negative 4 times negative 1 gives me positive 4. 4 times negative 8 gives me 32, or excuse me, negative 32. So I have 36 minus 32 to get 4. And 2 times negative 1 gives me negative 2 in the denominator. Okay, split it now. The square root of 4 is 2. So 6 over negative 2 plus 2 over negative 2. To get negative 3 minus 1, to get negative 4. 6 over 2 minus 2 over negative 2. Well, 2 over negative 2 is negative 1. Minus negative 1 makes this a one big positive to get negative 2. All right, hopefully that helped for today's problems. Have a great rest of your day. Adios.